In today's lesson, you will learn to divide polynomials. You should already be able to add, subtract, and multiply polynomials. The process for dividing polynomials is much like the process for long division. If you do not remember how to divide whole numbers by long division, you may want to check that tape before continuing with this one. As you go through the tape, be sure to take careful notes. If I should start any concepts, be sure to put those ideas and rules on your study sheet. We'll start today's lesson by recalling the distributive property. For real numbers a, b, and c, a times b plus c is equal to ab plus ac. In other words, I multiply the a times the b, I multiply the a times the c. Now let's go back and consider something similar related to division. Let's consider a plus b divided by c for c not equal to 0. Remember that to divide, one inverts and multiplies. Now that's understood to be c over 1. So if I divide, I'd have a plus b divided by c is equal to a plus b times 1 over c. To divide, you invert and multiply, or to divide, you multiply by the reciprocal. The reciprocal of c is 1 over c. Now we do have to note that c is not 0, so that we do not make a division by 0 error. Now by the commutative property, I can turn this around and write it as 1 over c times a plus b. That's commutative property of multiplication. Now I can distribute the 1 over c. I can multiply 1 over c by a. Now I can multiply 1 over c by b. So I can do the distributive property there. And I get 1 over c times a plus 1 over c times b. Now of course this is understood to be a over 1. That's understood to be b over 1. So when I multiply, I get 1 times a is a, c times 1 is c, and 1 times b is b, c times 1 is c. So we have a over c plus b over c. Well, what we've just discovered here is that division is also distributive over addition. I have a plus b divided by c. It's the same as saying c into a and c into b. In other words, I divide c into both of them. How can we use this property in order to divide polynomials? Well, we're going to start by dividing a polynomial by a monomial, because this rule applies directly to a polynomial divided by a monomial. So let's divide 8x to the 4th plus 12x cubed, subtract 6x squared by 2x squared. First of all, I'm going to rewrite it using the bar as my division symbol. So I can rewrite it as 8x to the 4th plus 12x cubed minus 6x squared all over 2x squared. Now according to the property I've just proven for you, you know that division is distributive over addition. So I divide the 2x squared into the 8x to the 4th, I divide the 2x squared into the 12x cubed, and I divide the 2x squared into the 6x squared. In other words, the 2x squared is to be divided into each of the terms in the numerator. So here I've written that. 8x to the 4th divided by 2x squared, 12x cubed divided by 2x squared, 6x squared divided by 2x squared. Now it's simply what we did a couple tapes ago, in which we do the division of powers. So 8 divided by 2 is 4. To divide powers having the same base, I keep the base and subtract the exponents. 4 minus 2 is 2. 12 divided by 2 is 6. To divide powers having the same base, I keep the base x, subtract the exponents. 3 subtract 2 is 1. 6 divided by 2 is 3. To To divide powers having the same base, I keep the base and subtract the exponents. 2 subtract 2 is 0. Now remember that anything raised to 0's power is 1. So my answer is going to be 4x squared plus 6x minus 3, because 3 times 1 is 3. Also note that x to the first power is the same as x, so there's no point writing that exponent either. So my answer, written in proper form, would be 4x squared plus 6x minus 3. Let's look at an example that's a little bit more complicated. Let's do 25 x to the 5th, y to the 9th, subtract 14 x to the 4th, y to the 10th, plus 7 x cubed y to the 11th, divided by 21 x cubed y to the 8th. Again, I distribute my division by dividing the 21x cubed y to the 8th into each of the terms in the numerator. So I have 28x to the 5th, y to the 9th, divided by 21x cubed y to the 8th, subtract 14x to the 4th, y to the 10th, divided by 21x cubed y to the 8th, plus 7x cubed y to the 11th, divided by 21x cubed y to the 8th. Again, divide the denominator into every term of the numerator. Once we get to this step, it's just a matter of simplifying as we did previously. Now, with my numbers, I need to deal with them as always. Since I really can't divide 21 and 28 evenly, I need to reduce. I reduce the fraction by saying what will go into both 28 and 21. The answer is 7. 7 goes into 28 4 times. 7 goes into 21 3 times. So 28 21st reduces to 4/3. Now to divide powers having the same base, I keep the base and subtract the exponents. So keep the base x, subtract the exponents. 5 minus 3 is 2. Keep the base y, subtract the exponents. 9 minus 8 is 1. I didn't write the 1 this time. It's understood to be the 1. I can put it in just to show you that 9 minus 8 is 1. Now here, we need to reduce the fractions again. I need to find something that would divide into both 14 and 21. What would divide into both of them is 7. 7 goes into 14 2 times. 7 goes into 21 3 times. So I can reduce 14 21st to 2/3. To divide powers that have the same base, I keep the base and subtract the exponents. 4 subtract 3 is 1. To divide powers having the same base, keep the base, subtract the exponents. 10 minus 8 is 2. Here I reduce the 7 21st. 7 goes into 7 1. 7 goes into 21 3, so that reduces to 1/3. To divide powers having the same base, I keep the base, subtract the exponents. 3 subtract 3 is 0. And with the y's, to divide powers having the same base, I keep the base, subtract the exponents. 11 subtract 8 is 3. Now the only thing I can do now is x raised to the 0th power is 1, because any base raised to the 0th power is 1. 1/3 times 1 is 1/3. So I can write my answer as 4/3 x squared y, subtract 2/3 x y squared, plus 1/3 y cubed. Now again, the changes I made: y to the first is y, x to the first is x to 0 is 1, 1/3 times 1 is 1/3. Let's look at an example of one that is slightly different, in that you're going to be left with a variable in the denominator of one of the terms.